Hello, this is a video about the Pythagorean theorem. Uh, Pythagorean Theorem. Sorry, that doesn't look too great. It deals with right triangles. And it deals with Pythagoras and his followers, maybe 300 BC. And they came up with this idea. If you have a right triangle, you have three sides, of course. Two sides are going to be smaller than the third side. The third side is this one along here. This along here is called the hypotenuse. It's always opposite the right angle, and it's going to be the longest because these two are smaller angles, acute angles. So we usually label these, the two smaller legs, we label A and B. They're called legs. And C is the long one, and it's the hypotenuse. And so Pythagoras said that A squared plus B squared is equal to C squared. And there's some relatively easy proofs for that you'll learn in high school, but for right now, we're just going to see how to work out some calculations. So let's say I had A is equal to 3 meters, B is equal to 4 meters, and I don't know what C is equal to. So I can say 3 squared plus 4 squared is equal to C squared. Well, we'll simplify on the left side here. We got 9 plus 16 is equal to C squared. 9 plus 16 is 25. Is equal to C squared. Well, if I take the square root of C squared, I'm asking what letter times itself is equal to C squared. Well, that would be C, which is what I want. I'll switch sides here too. And I'll take the square root of 25. What number times itself is equal to 25 is 5. So our answer is 5. Here the units would be meters. Okay? So that's the Pythagorean theorem. That's the simplest sort of way to do it. Here all A, B, and C are all whole numbers. Often that is not the case. So let me show you an example of that. So let me go here for a new drawing. And so let's say here I have my right triangle. And let's say I'm saying, I'll just make up some numbers. This is 6, and this is 7, and I don't know what this is. So I can say A squared plus B squared is equal to C squared. Notice I don't care which of these is labeled A and B, so it doesn't really matter. So this is A squared plus 6 squared is equal to C squared. Well, this is 49 plus 36 is equal to C squared. So let's say 50 plus 36 would be 86. So this would be 85 is equal to C squared. Take the square root of both sides, and we get C is equal to the square root of 85. Well, what number times itself is equal to 85? Well, you can't think of it, can you? Because there isn't a whole number that times itself is 85. We know 9 times 9 is 81. We know that 10 times 10 is 100. So we know it's between 9 and 10. And we know it's going to be closer to 9 because 85 is closer to 81 than it is 100. I'm going to bring up a calculator here, and I can go square root of 85, and I get, oops, I'm sorry, I have to go this way. And I get 9.219544457292887. Matter of fact, that keeps on going forever. I don't even know if that last digit is rounded or not. That's a lot of digits there. But it goes on forever and there's no pattern to it. And as we've learned before, we call such numbers irrational numbers. So the answer to it is irrational. That actually bothered the Pythagorean followers and Pythagoras a lot. They didn't like the fact that there might be irrational numbers. Let me show you another example here. So I'm going to get rid of this canvas and open up another one. And so let me open up this. And let's say I have now a right triangle. And instead of not knowing, let's say this is 7. And this is, I don't know what this is. I'll call it X. And then this one is 10. And it could be, we won't worry about what units they are. Well, here I want to find what X is. And X is not the hypotenuse here. It's one of the legs I want to find. So we know that A squared plus B squared is equal to C squared. Let's say we'll call X the A. So we got X squared plus 7 squared is equal to 10 squared. Simplifying, we get X squared plus 49 is equal to 100. We subtract 49 from both sides. And we get X squared is equal to 51. Square root of both sides. And we get X is equal to the square root of 51, which we know is going to be very close to 7 because square root of 49 is 7. It's going to be between 7 and 8, a lot closer to 7. We can bring up the calculator again. And so scroll up, calculator. Oh, that's the calendar, sorry. And let's try that again. Calculator. And we go 51 square root. This is standard calculator, so it's 7.14 on and on. And so we can say X is approximately equal to, what did it say? 7.14, let's say. 7.14. And we say approximate because we know it goes on forever and it doesn't repeat. So there we know how to find a leg. We know how to find a missing leg. We know how to find a missing hypotenuse. And so we will end this discussion of the Pythagorean theorem.